Okay, so we have 5i plus 7j, and we want to write that in polar coordinates. So we graph the point 5, 7 right here, and we want to write that in terms of theta, this angle right here, and r, which is the length of this line that goes from the origin up to the point. So to do that, we have this right triangle drawn. We brought the altitude down to the x-axis, and this short leg is 5 and the long leg is 7. So we will use the Pythagorean theorem to find r. So 5 squared plus 7 squared equals r squared. 25 plus 49 is 74. And so r is the square root of 74. And what goes into 74? Anything? Let's see. If you're not sure, you can always do the prime factorization. You've got 74, 2 times 37, and 37 is prime. So, no, there's nothing in there to take out. So, r is the square root of 74. That's real nice. Okay, now we have to find theta. So we're going to use tangent, because tangent theta is opposite over adjacent. So 7 over 5. So to find theta, we're going to use our calculator, and we will have to punch in inverse tangent of 7/5 is going to give us theta. So if we punch that into a calculator, we will hit 7 divided by 5 and hit the equal sign and then hit inverse tangent. And that gives us about 54.46 degrees for theta. Theta equals 54.46 degrees. All right, so one way to write the polar coordinates for this point would be to write the square root of 74, 54.46 degrees, or you could write it in the book's notation, which is the square root of 74, and then this bracket, 54.46 degrees. So the book wants you to write this in 4 different ways. So there are just an infinite number of ways that you could write it. One way to write it would be to make your angle in the opposite direction. So remember, this is 0 degrees, and when we travel around on this circle, the positive degree direction is when we go counterclockwise. And so that makes this 90 and this 180 and this 270. There's 90 degrees per quadrant, and you travel counterclockwise. So right now, the way we have it written over here is we're saying go 54.46 degrees counterclockwise, and then go out from the origin the square root of 74. That's how you get to this point. Another way you could get to this point would be to travel in the clockwise direction around the circle, starting at 0. That would be 90. Every quadrant is 90 degrees. So 90, 180, 270, and then this much more, okay, to get there. Well, what is that? That would be, if we went all the way around, that'd be 360. But we're not going all the way around. We're going all the way around minus theta. So we're not going all the way around. So back up theta degrees. So to figure out this angle of when we go clockwise, we call it a negative angle. So we're going to say 360 minus theta, because we're going not all the way around, but all the way around minus theta, then we would have 360 minus 54.46 degrees, which would be 305.54 degrees. So another way to write this point would be square root of 74, but the angle we would put would be negative 305.54 degrees. So that's another way to explain how to get to this point. You go clockwise 305.54 degrees, and then you go out from the origin, square root of 74. So that's the second way that we could explain how to get to this point. Now, it is easy to get confused about whether you're supposed to add this to 270 or subtract it from 180 or what you're supposed to do. So you have to consider what angle is theta. Theta is the angle between the radius and the x-axis. So theta is right here. All right. So in our situation, theta is 54.46 degrees. So let's, all right. So if you go around the circle, starting at 0, and you go clockwise all the way around, you are, as I explained before, you're going 360 minus 54.46. Some people want to add 54.46 to 270. So 90, 180, 270 puts you here. And then they want to add 54.46. But this angle right here is not 54.46. It's the complement of 54.46. So this angle right here between the radius and the y-axis is 90 minus 54.46. So that angle is 35.54 degrees. Now, if you had that angle to help you, you could add it to 270 and you would get 305.54, which is what we got. But that's not the angle we originally found. We found the angle that's inside the triangle, which is 54.46. So if you're trying to add 54.46 to 270 to get this, that won't take you to where we want to go at 5.7. All right. So you have to think about the circle, where you are on the circle, and what the values of the different angles are. So the angle inside of our triangle that we used the tangent to find is 54.46. And the only way to get there, going clockwise from 0, is to think of it as going all the way around the circle, but backing up 54.46. Another way we could get to where we're going would be to go, we could start at 0 and we could go counterclockwise all the way around into the third quadrant, kind of at the opposite side of this point. If we go over here, we travel all the way around to here, then we are traveling from 0, we're going to 180, and then we are adding another theta degrees because these are vertical angles. So this angle is 54.46. So when we go clockwise from 0 and we get to this point here, which is opposite of 5.7, we go 180 plus 54.46. So 180 plus 54.46, that is going to be 234.46 degrees. So if we do that, if we start at 0 and go around to that position right there, then we would want to draw our radius backwards because we want to get it back into the first quadrant where the point is. The point is here. We're trying to tell somebody, how do you get there? All right. Well, and the way you could get there is to go 234.46 degrees and then go backwards back into the first quadrant. So for this one, you would write negative square root of 74 234.46 degrees. So that is just another way to get there. Another way you could do it would be to you could just spin around the circle twice. You could start at 0 and go all the way around and back up again. So doing that, all you'd have to do would be to go back to your original answer and add 360 to the angle. So square root of 74, 360 plus 54.46 is 414.46. So this would be another way to write it. So there are an infinite number of ways to write these polar coordinates. You can just spin around the circle all day long, but you have to make sure you know what angle you're talking about. Don't just start saying, oh, I'll add it to 270 or I'll subtract it from 180. You have to think about the angle you're dealing with. The angle you're dealing with should always be the one between your radius and the x-axis. Okay, so here is another one where we want to change this to polar coordinates. So I didn't have the right graph paper for this, so just believe that that is negative 12 and 2. So you're going 12 to the left and 2 up, and you get to this point right here. So we will drop an altitude down to the x-axis to make a right triangle, and we want to find this angle. So we'll call it theta, and we will realize that the sides of the triangle, this is 12 and this is 2. So we know that the tangent of theta is going to be opposite over adjacent. So theta is going to equal the inverse tangent of 2/12 or 1/6, and we will punch that into our calculator. 1 divided by 6 equals, and then hit inverse tangent, and it gives us about 9.46 degrees for that angle. All right, but that is not the angle that will be in our answer. So first of all, also we need to find r, how far away from the origin you have to go to get to our dot, our location there, our point. So we need to use the Pythagorean theorem to find r. So 2 squared plus 12 squared equals r squared. So 4 plus 144 equals r squared. So r squared equals 148. R equals the square root of 148. I'm not sure if there are any perfect squares in there, so I will just do the prime factorization. 2 times 74. 74 is 2 times 37. So there is there's a 4 in there, so that is 2 times the square root of 37. So that's our R. So first of all, we want to know how we can write this in the most basic way. Starting at 0 degrees, we will go counterclockwise around the circle to get there. So we go this far to get there. And how far is that? Well, if we went all the way to the x-axis here, it would be 180, but we don't want to go 180, we want to go 180 minus theta, back up theta degrees. So 180 minus what we got for theta is going to give us 170.54 degrees. Okay, so one answer we can put is going to be 2 times the square root of 37 for r, and then theta 170.54 degrees. So that's one way to write it. Try to put all my answers over here. It's hard for me to stay organized. Okay, so that's one way to get there. Another way to get there would be to go in the opposite direction. Starting at 0, I could go clockwise. So if I do that, I will go 90, 180, and theta more than that. So 180 plus 9.46 is 189.46. So I could do that. I could go in the the clockwise direction, which is the negative direction, and I would have 2, sorry, that looks like a negative, 2 square root of 37 for my r still, but I would have negative 189.46 degrees for my angle. Another way I could get there would be to go this way. I could go again clockwise and just go this far into the 4th quadrant, and then instead of going this way like I normally would, I could go backwards with my r. All right, so this means I'm going theta degrees in the clockwise direction, so that's a negative angle, negative 9.46 degrees, and I'm going to go backwards with my r to get into the 2nd quadrant. So that's going to be negative 2 square root of 37. So that would be another way to write it. Another way would be to, let's see, we could go, well, we could just spin around the circle an extra time. So when I go the normal way, which was right, let's see, here, the first one I had, I can just add 360 to that angle. So 360 plus 170.54 is going to be 530.54 degrees. So that would be another way to write it. 2 square root of 37, 530.54 degrees. So let me just make sure you understand what I did there. I just started at 0. If I can get my pen, there we go. Start at 0. I went all the way around the circle, 360 degrees, and then I went again another whatever we got at the beginning, 170.54 degrees. And it put me right there, and then I used the positive r because I was in the 2nd quadrant. So, like I said, there's many, many, many ways you could do this. If we wanted to do it and get another negative value for the radius, we could travel in the positive degree direction around to that 4th quadrant. I'm not making a very good circle here. And instead of coming out like this, which we normally would, we go backwards. So we come around, we go 90, sorry, you can't see that very well. We go 90, 180, 270, and this much more. But since we didn't get that angle, we can just say, all right, if I went all the way around 360 and then I back up theta, that's 360 minus 9.46, and that's 350.54. If I did that, I would be spinning around to that 4th quadrant and then going backwards with the r. So I'd have negative 2 square root of 37 and 350.54 degrees.